The question reads, a bus is traveling on a horizontal road at a velocity of 126 kilometers per hour when the bus driver notices an object in the road. The brakes are applied and the bus is brought to a rest over a distance of 150 meters. The frictional resistance is 2,500 newtons and the bus has a mass of 6,000 kilograms. So it's a 6-ton bus. They ask us to calculate the retardation of the bus. Okay, so let's have a look at the question. All the values given are in our MKS, meter, kilogram, second, except for 126 kilometers per hour. We need to convert that to meters per second. So let's do the conversion. 126 kilometers per hour, 126 kilometers per hour. What do we know? Kilo means 1,000, per hour means divide by an hour, but we want it in meters and kilograms, so it must be 126 kilo times 1,000 divided by h, which is in hours. So, but I need it in seconds. How many seconds in an hour? There's 60 seconds in a minute and 60 minutes in an hour. So that's 3,600. Let's call up the calculator. I'll just check that answer. 126 times by 1,000 divided by 3,600 gives us an answer of 35 meter per second. So now we have all the values in MKS. Now we can answer the question. The first question says, number 1, calculate the retardation of the bus. So in other words, we want to know the braking force or the deceleration. So what do we know? We've got velocity, initial velocity. The final velocity will be 0. We have the displacement, 150 meters. We don't know what the time is. Okay, so which formulas do we have? V squared equals U squared plus 2AS. Displacement, acceleration is what we want. We have the initial and we have the final. So we can work it out. 0 squared, because that's the final velocity, it came to a standstill. The initial is 35 squared plus 2 times the acceleration times 150 meters. So we want to solve for acceleration. So acceleration will be 0 minus 35 squared divided by 300 is equal to A. Where does the 300 come from? 2 times 150 is 300. So call up the calculator again. 0 minus 35 squared is 1225 divided by 300. Gives us a nice fraction of 49 over 12. Let's convert that to decimal. 4,083. So minus 4,083 meter per second squared is what the acceleration is. Note the negative. Why is there a negative? Because it is slowing down. The acceleration is negative. Okay, let's have a look at the next one. Let's change colors for question 2. Question 2 says the time taken, t, to come to a complete standstill. Okay, so what do we know? We've got the equation of v is equal to u plus at. We have the final velocity, which is 0. We have the initial velocity, which is 35. We've got the acceleration because we've just calculated it. We need time. So 0 is equal to 35 plus, now it's a negative, and don't forget to include the sign. 4,083 multiplied by t. So let's solve for t. T is equal to minus 35 divided by minus 4,083. So T must be equal to, let's get the calculator again. That's a negative, so we've got 35, negative 35 divided by that gives me a grand total 8,57. 8,57, and the unit for time is second. If you ever end up with a negative time, you've done something wrong. Time cannot be negative. Okay, we're going to look at the last question now. The last question says the braking force of the brakes. Okay, what do we have? We've got a bus. It's moving, let's say to the right. It's arbitrary, it doesn't matter. There are two forces acting on it. One is the frictional force, which is opposing the direction of motion, which was given as 2,500. And we have the force of the brakes working on it. Okay, so now if we've got an object in motion and it is being accelerated or decelerated, it doesn't matter, there's an acceleration happening. The formula that comes to mind is Newton's second law. F net is equal to mass times acceleration. So let's have a look. Number 3. F net. I need, what is the net force acting on the bus? The net force acting on the bus is only two forces, and they're both acting to the left. It's the force of the brakes and the frictional force. And that's equal to mass times the acceleration. So force of the brakes is equal to mass of the bus times its acceleration minus the frictional force. Let's substitute the values in that we have. The mass that we have was given was 6,000 kilogram. The acceleration of the bus we've worked out was 4,083. Do I worry about the negative now? No, because it is the acceleration of the bus. The force experienced is the acceleration multiplied with the mass minus the frictional force was given as 2,500 Newton. Let's put that into the calculator and see what we get. So we will have 6,000 times the acceleration, 4.083, multiply them, and we need to subtract 2,500, gives us 21,998 Newton. And there we go, done.